There are many different ways to approach construction of a bee vacuum. The following is our offering. This system consists of 3 basic units plus a brood box, which you will also have to supply. Working from the bottom up, the first item is the base unit. Next is a screen unit, and finally, the top or upper unit. We offer these simple plans of which you can do a screen copy or simply pause the video and write down the dimensions. Later in this video, we will show you a complete list of materials. We use 3/4 inch pine and poplar wood for our unit. All 3 items are 16.5 inches wide by 19 3/4 inches long to accommodate a standard 10-frame brood box. The height of the 3 units we designed varies. However, you can use whatever dimensions you feel are appropriate. We designed this system to be used with a standard shop vacuum with a 2.5 inch dust collection hose. The base unit is 4 inches tall with a 2.5 inch round hole for the vacuum opening. We purchased 2 PowerTech 2 1/2 inch universal dust collection fittings, which are available at some hardware stores or Amazon. These are items which accommodate most shop vacuums. One is mounted on the base unit over the 2.5 inch hole. The floor or ramp of the base unit was cut from a 3/4 inch by 24 inch by 48 inch laminated pine board available at most home improvement stores. We found ours at Lowe's. You will use some of the remainder for the top section. Make sure you cut 10-degree parallel angles across each end of the 3/4 inch by 15 inch by 18 5/8 inch ramp so that it seals good when assembled. You can also caulk the edges on the underside if you wish for a better seal. We also mounted 2 hooks on either side so that a ratcheting strap could be used to hold the complete unit together. You may choose to seal and paint the exterior. We recommend you not paint any of the interior of the 3 units. We also used 1/4 inch thick foam tape on the top side of the base unit to obtain a good seal when vacuum is applied. The second unit is the screened section. This keeps bees in the brood box. We use poplar wood for this unit because it is a stable product and it also holds fastenings well without splitting if you drill pilot holes. We used number 8 by 1 1/2 inch wood screws throughout. Our screen unit is slightly more than 1 5/8 inches high and is actually 1 11/16 inches high. This allowed us to set our table saw to 3/8 inches above the table to create the slot for the screen. This is a drawing of what the back and sides should look like with a slot. Use a scrap piece of wood to check both the depth and width of the slot. Use a scrap piece of wood to check both the depth and width of the slot you will cut into each of the 2 sides and the back. We used 2 passes to get the width of the slot to our liking. You may want to construct the screen before beginning this part of the project to make certain you have enough clearance to smoothly insert the screen. We kept the thickness of the slot to just slightly more than 1/8 inch to keep the bees in even when the screen is removed. We used wood glue on each joint throughout the project. The screens should be 15 1/2 by 20 inches long and no more than 1/8 inch thick. We made 2 screens, one with wood framing and another using a thick piece of paperboard normally used as backing on picture frames. We liked the paperboard frame best, which was about 1/16 inch thick and can be cut as a single piece using a razor knife. We found ours at Hobby Lobby, but many craft and picture framing stores carry this product. Be sure you use aluminum screen and not vinyl. To begin with, we cut the screening about 2 inches greater all the way around, as this made it easier to obtain a flat assembly for gluing. We placed the rolled side down on a flat surface over the frame with the curved sides up. we laid scrap pieces of wood on each edge to hold the screen in place. Be sure to keep the screening square with the frame, as that makes it easier to trim with scissors when finished. We purchased epoxy glue to secure screening to the frames. This can be purchased in a twin tube at most home improvement centers. We suggest you put the glue in the refrigerator overnight. Although this makes it more difficult to force out the two portions of glue, you will have more time to brush over the screening and onto the frame. This is especially important if you are working in a warm environment. We used a flat, smooth piece of wood to mix the glue. This keeps it spread out and avoids a large mass, which creates heat and tends to quickly kick off the glue. After the glue has set, trim off the excess screen material. Then brush a sealer, such as polyurethane, onto the other side of the frame. Be sure to get the edges as well. This will produce a moisture-proof frame which should serve well for years. We also made a wood frame by cutting 1/16 inch by 3/4 inch strips of poplar wood. Clear pine should work just as well. Mark out a pattern with perfectly square corners on paper and tack the wood strips down with a stapler or tape. Apply the screening in the same manner as with the paper board. When finished, you may have to sand the edges of both the paper board and wood frame screens to make certain they slide smoothly into the slotted frame. We used a sanding block with 120 grit sandpaper to smooth the edges. We put foam weather stripping onto both the top and bottom of the frame holding the screen to assure a good vacuum seal to the brood box and the top section. The top unit is critical in the sense that it requires both the ability to apply vacuum to the entire assembly and to control the amount of vacuum needed to efficiently capture bees. We used a 3-inch tall frame to provide adequate space between the screen assembly and the vacuum port. We made the frame from 3/4 inch poplar wood. You can get the dimensions from the material list shown later. In the center of the outer frame is a wide board measuring 3/4 inch by 15 inch by 18 1/4 inch pine, which was left over from the edge glued board we used for the sloped ramp of the base unit. Perhaps the most important part of the top unit is the gate or slide valve used to control the vacuum. We drilled two 2 1/2 inch holes in each end of the center section of the top unit. The location is not important, but be sure to leave enough clearance from the edge for the sliding valve. Although we got a bit fancy with the plastic slide valve shown here, you can cut pretty much any thin material long enough to completely cover the vacuum vent hole. Here is a drawing of a simple solution using a thin piece of material which is secured by a screw. You can rotate the valve plate to obtain optimum vacuum. Make certain you secure the valve cover tight enough to hold the valve in place once you begin using your bee vacuum. Next, secure the remaining dust collector fitting over the other 2 1/2 inch hole. This is where you will attach the hose from your shop vacuum. Although not necessary, in the center we installed a square piece of glass so we could look into the box to see how the vacuum process is working. If you draw too many bees up onto the screen, you can kill them, so you need to adjust the vent valve so that enough vacuum is applied to just draw bees into the suction hose. This should not take too much vacuum, as they will be easily drawn into the box once they are inside the hose. To make a more professional statement, you may want to purchase a 10 or even 20-foot section of clear PVC hose used to capture bees. For added convenience, you can also purchase a 2 1/2 inch hose-in fitting, such as that shown here, which is inserted into the clear hose. Here is a list of items and materials you will need in order to build this particular bee vacuum. You can either take a screenshot or perhaps pause the video and write down the materials. Well, there you have it, our idea of a bee vacuum. If you have any comments or suggestions, please send them to us at ernest37@gmail.com. Thanks for watching. Bye now.